This presentation is brought to you by Alpha Echo, specializing in security advice and enterprise-wide cyberworthiness. Telstra, we're always better together. Nui Tech People, created to build strong tech communities.
I am going to talk about web APIs. The talk is probably time-wise not very structured. I do want input, I do want questions, so keep them for the end. I have a block at the end where I want your thoughts on APIs, if I misrepresented or completely missed the API that you love the most, or if you have any thoughts about the ones that I mention. Otherwise, the talk has two parts. The first is a very quick introduction. Why is this important? Why does it matter to start with? And then it's going to be pretty rapid fire, me just going through a bunch of web APIs that I think are interesting to know about, exciting to know about if you know how to use them, and you may or may not have heard about before. Cool. That out of the way, first part, introduction. That works. Cool. The reason why I think talking about web APIs is important is progressive enhancement. There's so much potential in enhancing our apps that we build for our customers in a way that we deliver value in a sensible way. And what does progressive enhancement mean? Taken from the MDN Mozilla docs, progressive enhancement is a design philosophy that provides a baseline of essential content and functionality to as many users as possible, while delivering the best possible experience only to users of the most modern browsers. I think we can generalize that a little bit more. And for me, at the end of the day, it comes down to that accessibility piece. So first of all, it's a design philosophy. This might have sounded like a dev talk in the description. This is under the cover. It's actually a hidden UX talk. Sorry about that. It's a design philosophy. It's how we think about user experience under the hood. It provides a baseline of essential content to as many users as possible. That's the accessibility part. We need to make sure that no matter what the core functionality of our app, everyone can access it. So no matter where they access your app from, no matter what device they use, whether they have like a keyboard, a mouse, or they use other input devices for various reasons. And then the browser part definitely becomes part of that, whether they're on an old browser version, a new browser version, a mobile browser, whatsoever. They might be using your app on a TV screen. So all things to keep in mind when thinking about, when I'm building this feature, how can I make sure that this is still working, even if not all of the modern technologies behind it are available to all the users? So huge disclaimer when we talk about web APIs, because not only the browsers, but there's a lot of other things that come in that can prevent users from being able to access those features. We need to make sure that we build stuff in a way that even without them, they can still use your application. The other part, besides the progressive enhancement, the other part that I think is worth thinking about is how did we even get to where we are right now? So we used to build web apps. Again, I've done it now for 15 years. When I started, it was pretty limited in what you could do. It was the jQuery days where jQuery was really helping make it accessible across like Internet Explorer 6 and like the new Firefox that came out and whatever. But the functionality in the browser itself was pretty limited. So I don't know, I might sound like an old person here, but who remembers building copy-paste behavior with Flash because you couldn't do it with a browser? One person. Cool. We talk after this. Other things like where file pickers and all of that stuff, where we very quickly realized limitations and then just ended up building native applications, be it for desktop, be it on mobile, where you need mobile features to work with your app. But with frameworks like jQuery, we also realized JavaScript is super powerful. Like we need to use more JavaScript, or we wanted to use more JavaScript. And so we started, I'm using PhoneGap as my example here because I think it's underrated. Like people don't talk about it enough, how much it unlocked from a developer experience perspective, from how do we think about building apps, making that accessible to everyone. At the time, it might have not been the most stable and whatever technology, but it was trying to break the barrier, trying to be able to use JavaScript to build mobile apps, and then break into that through bridges that I'm just describing it magical here, being able to use native features in your JavaScript app, essentially. So PhoneGap, for everyone who doesn't know, is now Cordova, and it's basically bypassed now by React Native or similar frameworks that try to achieve the same thing. You're building in JavaScript, but you have a bridge that gives you access to a lot of native features. The reason why I started giving this talk a couple of years ago was that I had a conversation with one of my coworkers about like a feature that we wanted to add to our platform. And very quickly, he just jumped on we need to access the context of the user's device. We can't do that in JavaScript, so we have to build a native app. And it's like, I think it's really interesting to see what those modern browser APIs are that are available now or will become available, that started adopting a lot of the functionality when we saw how much we started building native apps just to access certain functionalities. So that's the other part to keep in mind. If you're currently building a native app for a certain thing, there might be web APIs out there that give you that even in a web app. If you're thinking about building a native app, but it's not worth it, but you're then thinking like, oh, I'm missing out on a feature, you might actually not be missing out on features. So those are all my disclaimers. Let's look at some browser APIs. For that, to put it into a more real-life context, to show how you can actually use those APIs in a real application, I built a demo app. It's actually, you can go to stopme.io. I bought that domain. I paid $20 just to give this talk. It's the ultimate SaaS app, SaaS obviously standing for Stop as a Service. It's literally just a timer and a countdown, and then it has a bunch of functionality that we go through of like how we can enhance the experience. I'm going to start with some APIs that might already be wider known, and I'm going to explain why. Observe your app, the first category. Resize Observer. So again, this has been around for a while. Most people might be aware of it. The reason why I'm mentioning it here is to show that it's still powerful and still relevant. So Resize Observer is a JavaScript API that allows you to observe specific elements on your page, and you get notified whenever they resize. So that used to be super powerful because we didn't have container queries in CSS yet. So to actually implement responsive behaviors of your site, you needed to have that kind of observability. But even now that we have container queries are somewhat limited. You have to have a known min width and aspect ratio of that element. It's still worth being aware of the power that Resize Observers actually come with. And this is where I justify that this is a dev talk. I have code snippets that I quickly run through and explain how it works. So for the observers, they all work in a similar way. You have a callback that gets called every time the observer triggers. That gives you all the entries. The entries are based on the elements that you're observing, so that could be multiple, so it's always an array of elements. And then you can loop through them and get the information based on the observer that you have. So for the Resize Observer, we would create an instance of that observer. We define the elements that we're listening to, and then we observe, and it gets triggered every time with a content box size, every time the size of the element changes. Don't be me, don't forget to unobserve. If you have an application that's long-lived, this observer will stay around if you don't call unobserve at the end. So especially if you work with React and you have like a use effect, clean up after yourself. The other observer that I want to mention is the intersection observer. It allows you to observe when elements come into the viewport, go out of the viewport. It tells you how much of the element is visible in the viewport, etc. Code-wise, again, it's very, very similar. You create an instance of it, you pass the elements that you're observing in, and then you get information like a Boolean is intersecting, the actual rectangle, what's intersecting, and all of that stuff. The reason why I'm mentioning it here is quick show of hands, who's using front-end frameworks like Next.js, Remix, Astro? Okay, not too many. Highly encourage people who build on the web to use those frameworks. Those frameworks are exciting right now. When we think about Astro and Quick specifically, They're trying to set the boundaries of like being smart about how we load less code on the browser. Quick is a really good example of being very aggressive with code splitting. So every callback is going to be its own bundle. And it uses Intersection Observer to make sure that it only loads the stuff that the user actually sees. So it's avoiding loading excessive amounts of JavaScript just because you build a huge application even though the user doesn't see 98% of it. But we can observe more. We can observe the user's device directly. So this is where we get more practical in our stopwatch application. Network Information API. I haven't mentioned it before, I have indicators for browser support underneath it. I will mention it in the beginning. I won't go too much into it. You will probably notice why there's a pattern that you will see. The Network Information API is supported in Chrome and Chromium browsers, so Edge and any other Brave and whatever else is based on Chromium. It gives you the information of what kind of network connection the user currently has. And this can be super powerful for multiple things. Before I start talking about that, here's where I point out the progressive enhancement bit. Check whether or not a feature is enabled. Don't rely on that feature being there in the browser for the core functionality of your feature, but when you know that it's there, you can enhance the experience of the user. So in our case, what we could easily do is we basically check the connection that the user currently has. It gives us a type. That could be Wi-Fi, that could be whatever they use to get the internet. The effective type is basically just a subset of that, so you can do more concrete stuff. A downlink max, that's basically the speed that you can expect. Those are rough estimates, so they're not always super accurate, but they're a good indicator. RTT and safe data. Safe data is an interesting one. That's the user specifically saying, like, I want to use less data on my device if I can. Use that. If you have like data-heavy stuff in your application, you can use that to avoid doing that data-heavy stuff. And if you can't do that, use that to warn the user of like, hey, if you press this button, you will probably process X amount of megabyte. Really valuable to make sure the user feels like you're actually acknowledging their settings. But even just the downlink or the type can give you an indication of like, cool, I know my user is on a slow network, so maybe I load the smaller version of the video or the smaller version of these files. Again, all in the idea of, even if you don't have that information, it's still functional, but it's better when you have that information. I think that's actually a wrong screenshot. Pretend you see that in a second. No, actually it is there. So what I have here, what I don't have here in the slide, you can also just check whether or not the user is online. But I have a separate set for that. But this is where you see it in action. When the user is offline, let's pretend the stopwatch really needs internet connection. You can show a warning of like, hey, you're currently offline. Some functionality might not work. Products like Canva are really good at that because they can still save on your device until you're online again and then resync back. Page Visibility API. All browsers support it. It's been around for a while, so again, you might already know it. It allows you to see when the tab that runs your web application goes into the background or comes into the foreground, so you know whether or not the user is potentially looking at it. Again, this becomes really powerful when you have processing heavy stuff that's happening in the background. Say you're polling your API every 5 seconds to get like the latest information from your server. If your website is in background, you know that you don't need to do that. So you can stop processing heavy stuff. But you can also acknowledge that, okay, now the tab is in the background, maybe super important information, and this is probably like dark UX, so I'm not a designer. Say you have a notification bubble in your app, and you know the user is on a different tab, you could show the number of notifications in your tab title. And this is all you really do is document hidden gives you whether or not the document is hidden, and visibility change on the document as an event listener will trigger every time that value changes. So it's literally just that Boolean that you care about. And in our stopwatch, what we could do is say I start a timer, but then I need to go to another website. I could actually put the timer into my tab, so I don't have to switch back to know how far along I am. And it's those small things that can really enhance the user experience without destroying it for someone who doesn't have that feature. Battery Status API. Again, similar to the network, this is only available on Chrome and Chromium browsers. And even there, I recently found that it's getting less and less accurate, but it's still valuable information. So Battery Status API, like the name suggests, it's probably actually worth mentioning. Web APIs are surprisingly well named. Naming things is really hard in dev, and these are just, you can tell what they do. Battery Status API gives you the status of the battery, whether it's charging at the moment or discharging. If it's not charging, how much time estimated is left, all of that kind of stuff. It's slightly different to other APIs. It's using promises. So promise-based, you can use Navigator get battery. That gives you the information. And with that information, you can basically then create event listeners that trigger whenever stuff changes. So whenever the level changes or the charging, whether it is charging or not changes, you can do stuff. And again, very similar to the network availability, we can use that in our app to basically tell the user, okay, we know you're currently not charging your phone. You put in a timer for over 2 hours. We know your phone is going to be dead by then. Let's put a warning in there. You might have an application where a user submits something and you know that processing will take like 20 minutes. And you show a loading bar, but like the laptop or the phone might die during that process. Being able to show that warning can be super powerful. What I mentioned before of like it's getting less accurate is on Android, it seems to have defaulted to like just infinity for the discharging time. I don't know if that's a privacy thing or not, but just something to be aware of. Enhance your components. So this is kind of like we're looking at observing the user's device and enhancing the application in itself. There's web APIs that help you just build better components or make components that you already have better. The screen wake lock API might be an edge casey one. For me, it's interesting because it's relevant at my day-to-day work, but also for this fake application, it's interesting. So screen wake lock allows you to prevent the screen of the user to go into sleep mode. So if you have something where you know the user is not going to tap on their screen or interact with your app for a while, but they want to see something, if they read a long text, or I would say watch a video, but the video API helps with that. But like in general, if you don't want the screen to go to sleep, you can lock that. And the way you do it is with Navigator wake lock. It's a request kind of API. So you have like a promise-based, you send a request to lock the screen. The device can deny that request. It's usually when the battery is already low and it would take up too much battery. But it's not a request in the sense of like the users will see a notification or anything. So this is purely in the background. It allows you to lock the screen wake and then release it whenever you think it's safe. So again, in our application, yeah, I don't have a screen recording because you don't really see anything happening other than you see that nothing is happening. But what we could do is the moment you start the timer, we lock the screen wake. So if somebody is setting a timer and starts cooking and they just want to see the time going on and it doesn't go into sleep mode, the visibility is always there until they stop the timer or pause it, and then we release the lock, essentially. Next API, Vibration API. So this goes more into a direction of, I've seen it very often that it's undervalued how much haptic feedback or any kind of like visual, audio, etc., can actually help users understand your app. So Vibration API is just one example because I think it's the most powerful. With audio stuff, if you want to send audio like sounds as part of your app, that's always limiting because, again, accessibility-wise, not in every situation you want your phone to make a noise, etc. Like in public scenarios, I don't want that. Vibration is pretty close to the user and not that disturbing. Again, the name is clear. It allows you to have the device of the user vibrate in certain patterns. It's also pretty straightforward. It's literally just Navigator vibrate and you pass in a duration. or an array of durations. And if it's an array, it's just the first number is the duration for the vibration, then the pause, then the duration, pause, etc. So that way you can easily create patterns that help kind of do whatever you want to do. With vibrate 0, you just stop the current vibration that's going on. This can be powerful in multiple ways, but for me, it's the most powerful is that haptic feedback when you have inputs. So a couple of years ago, when I changed my bank, I downloaded the app and I used the app, and I was immediately like, oh, this app is so much better, because when I put in the PIN, it had a slight vibration on it. And it was just like subconsciously that made me feel like, oh, this is a good app. So it's those little touches that you can add. In our case, also want to mention, there's whole websites and blogs and Reddit threads that purely are there for like, okay, what patterns of music and popular themes of, Super Mario, Star Wars, James Bond, etc. You can literally copy paste those patterns and make Easter eggs on your website. So if you go into the stopwatch, and you can find all the other Easter eggs, but here's one of them. And you have the timer, and the timer goes to 0. In general, I think it's a helpful feature to have the phone vibrate when the timer goes to 0. So again, let's think about that cooking scenario. My user is doing stuff and the timer goes to 0. They want to know that even though they're not looking at their phone. And you can add Easter eggs to then have the, trust me, it vibrates. The recording, again, doesn't really help much. But have Easter eggs where funny things happen when you have like a certain name of your timer or whatever. Eyedropper API. I was super excited when I found that. I might be spreading rumors here. I was told that this was also like kind of brought into the browsers with a lot of help from the Canva team, which makes a lot of sense. But this basically allows you to have a native, or use the browser's native functionality to allow the user to pick colors from their current screen. And this is not just from your app, like not from within the browser window. It's the whole screen, so that it's a native picker essentially. So if you have any kind of like users on your platform can customize their brand and they can pick a color, having that color picker where they can literally just go and go to their PDF where they have the brand colors open and pick from there is super powerful and makes it much quicker. Since it's a more recent API, it's also, again, promise-based. It is one of those APIs that needs to be triggered from a user interaction. So you can't just trigger it willy-nilly. It needs to be a click or something else that the user actually did to the website. So that's why here it's nested in a click event listener. But then you can just go eyedropper open. It will catch, like it would throw an error if the user cancels the interaction. So if there's no value selected, you need to handle that. But otherwise you will get a result, and that result has a hex code that you can then use for whatever purpose you want. So in this case, we have our timer. We want the user to be able to customize the color that it's rendered in. Again, it's the whole screen that you can pick from. And this is also, again, a really good example as a reminder, and I know I repeat myself, but this is the main message that I hope you take away from this. It should be a progressive enhancement. It shouldn't just be the picker that then allows you to pick any color. If the picker is not available, I still show a palette of like predefined colors. It's just for the users that have that functionality available, I can add it and enhance their experience without breaking the experience for everyone else. So this is also why I see here, on desktop, I can show that. On mobile, I would just not show that picker. Almost as good as native then goes a step further. This is what I kind of opened the talk with, of functionality that people often are just not aware that it's available. And I'm as guilty as anyone of that, of like just stumbling across stuff and it's like, wow, this is super cool. And then I realized, oh, wow, that's been introduced like 4 years ago or something. There's two big ones that stand out for me, probably more, but the two big ones that I want to go through. Browser support is a big one here. So definitely, again, be aware. Right now, it's only Chrome, not even Chromium. The Contact Picker API. Contact Picker API again, like the name says, allows the user to pick from their system contacts. And then you can do stuff with that information. So again, super powerful. Say you have an application that the user keeps track of contacts or can invite people to, or whatever it is where you would need contact information, you could allow them to pick those from their system without having to remember them. Promise-based API, Navigator Context Select, very similar to the Eyedropper API. It will resolve with whatever has been selected. And the difference here is it doesn't need to be triggered by user interaction, which I found weird, but apparently that's how it is. And basically what you pass in is an array of strings of like the information that you want. So in this case, we ask for the name, the email, the phone number, and the icon. And the user will see that that's going to be exposed when they submit it. And then you have the option whether you want single select or multiple select. But that's all the control you really have. And then what happens under the hood is that it uses the native behavior. So it opens, in this case, the Android contact picker. And the user will feel like they're within an app. And then they select the contacts, they submit, and then it returns to your app with that information. And you can, again, do whatever you want with it. So if we wanted to share our timer because we want everyone to know how long an egg should cook, that's an easy way to do it without people having to type in like an email address or a phone number manually. Slightly more exciting because it's much wider supported. Firefox added support very recently. It's just still behind a setting flag, I think. But the WebShare API is in a very similar sense. I'm pretty sure everyone who builds like a SaaS product has a share on Facebook, share on Twitter, whatever. And usually what we do is we just have that web link that adds the title and an image in the query string parameters, and then leads to those websites. That's very limiting. It also feels like we've passed that by now. It's 2024, yeah, something like that. WebShare API takes advantage of the native share functionality. So again, your device already has a share functionality in it. Why shouldn't we be able to use it? Very similar to the other APIs. This one needs to be triggered by a user interaction. The Navigator share promise-based triggers that native UI, and it catches when any error occurs or the user cancels out. And the share data we can pass in is a title, a text, a URL, and actually optionally also some files. I think Firefox doesn't support files either. But the fact that URL and files are there makes it super powerful as a sharing option in your app if you want to share with anyone outside of your application. And what it means is it, again, literally pops up that native UI, hopefully. Yeah, I don't know why I added the emoji in the video. But yeah, so we can see the native UI, and the power of that is the native UI knows what apps you have installed, what capabilities those apps have to share content. This goes way beyond our like share on Facebook text buttons. So again, a super powerful way to share information quickly outside of your app and increase kind of the value that users get out of it. This one deserves to talk on its own, which I will probably do at some point, but I still want to mention two APIs that I think are super exciting at the moment to deal with authentication. The first one is the Web Authentication API itself. So like I said in the last slide, it's passwordless. That's the whole idea of like we're moving more and more towards our APIs getting smarter and smarter how we can build safe applications. The Web Authentication API was basically built to either allow it as like a first layer, but mostly for a second factor authentication to allow the users to use their device to authenticate themselves. And all you really get and have to deal with is the public key and what comes with it. And then you send it forth and back. It's different from all the other APIs that I'm mentioning here because it's actually front-end and back-end. So there's a little bit more involved. But I think it's super exciting to see where those things are going. From an API itself, you have Navigator credentials. And on there, you basically just have create and get. You can create the credentials that you want to store in the database. So if somebody registers, you're going to create something, you're going to use a public key, and you're going to use a challenge that you generate on the server. That's for you to see if anyone has messed with it in between. And if they come back and they authenticate, you use get with the public key and the information that you stored on the server to verify that they're really who they think they are, or who they say they are. And that allows you to very quickly implement passwordless authentication, again, mostly as like a second layer at this stage, into your application without having to deal with like major frameworks or anything like that. In practice, you're still probably gonna deal with abstractions. So there's libraries out there that wrap all of this logic. The browser API is pretty concise, but what those libraries wrap is mostly the whole, you have to create a challenge data string. You then have to compare these. You have to deal with like the public keys for those comparisons. All of that is abstracted out with something like simple web auth as a library. What that looks like is, again, you get all of that native behavior. So on your device, it will just use passkeys. It can use your saved passkeys, and it will use any kind of authentication method that you allow, but also that the device supports. So for phone, it's like the pattern unlock or your fingerprint or face recognition, whatever you use usually for authentication, you can use for this. The server at the end, like my application, doesn't see any of that. Like it doesn't need to know about it. It doesn't get any details about it. All it gets is whether or not you're successfully authenticated. And on an iOS, macOS, for example, you can also see, again, the usual methods that device supports, even going through like my phone and sending like authentication requests to my phone because I've used that in the past and I set that up. So mainly mentioning that for awareness, this is super powerful and this will become more relevant in the future. Not going to go much further into it because I would talk for like an hour and a half just about that. The other one, personally for me, probably even more exciting, is WebOTP. OTP stands for one-time password. I'm pretty sure everyone in the room has come across it at one point or another. The idea is that you get a temporary, or you try to authenticate. The service gives you a temporary code that gets sent to your phone, and then you type in that code, and then you get logged in, and that code is basically used. What the WebOTP API allows you to do, at least in Chrome or Chromium browsers, that's the pattern that you can see coming through this talk, is like most of them are driven by Chrome. I want to be clear though, like I don't shit on Safari and Firefox for not supporting a lot of these APIs. It's like Chrome is driving it. Chrome is also driving it with a lot of like their opinionated ways of doing things. So other browsers not immediately picking that up and saying like, okay, whatever Google does, we do as well, is probably healthy for the ecosystem. So, sorry. So the WebOTP API, like I said, it allows you, or OTP in general, the idea is as a service, you send an authentication code or verification code to the user then types it in, you verify that it's the same code, and then you do something. What the WebOTP API allows you to do is intercept that and be able to say like, okay, I'm about to send the user an SMS with a code. I know that. And because I wanted to make it super convenient for the user, I want that code immediately to be put into the input when I detect that the code was received. So if they're on the same device that you're sending the code to, it's immediate. And I'm sure you know the native functionality of that, of like iPhones and Androids introduced that years ago, of like, if they see that something is coming in that looks like a code, it gives you the quick of like, just copy the code from there and put it in. This is very similar to that, but just through the browser. It really just works through letting the device know that you're about to send an SMS. So you would do the whole navigator credentials get before you send the SMS. But then there's no extra like security that you do anything on the device or on the server. All of it really uses is a format that the SMS has to have. And that format needs to follow those rules of like the code needs to be in the text. And then there's 2 new lines, and then your URL that you want to use for the verification, and again, the code with a dash in it. And then you can do stuff like this, where to get like a blue tag on our super awesome stopwatch app, you can send your phone number in. This is where you have to verify as a user that you're okay with this being listened to. So there is a kind of like request to the user. The website tries to do this thing. But then it basically just automatically goes through. It will wait for that SMS with that pattern to come in. And then you can do whatever you want with the result that comes back. So you can fill that into a form and automatically submit the form, or whatever you want to do with that information. And the only downside is that the user has to approve that action. I don't think it's a downside per se. I think it's just the UX of it is not very friendly. Like it could be nicer if just like a small notification. Right now it still pops up as a slightly scary, this website might be doing something dodgy kind of stuff. One thing that I want to mention on this as well is, this is actually super cool, and I just realized that when I was preparing for this talk. If you have your Chrome profile connected across devices, this allows you to push that code to the other device. So if I was doing the request on my desktop, if I was doing the request here, one way or the other, in my head it made sense before, but basically I can push the code to my desktop device because the Chrome profile is linked, which is extremely powerful. And I think the more stuff gets added to this API, the more amazing it becomes. Cool. I have 8 minutes left, roughly 5 minutes. We'll bargain about that. I have some honorable mentions that I don't want to go into, or I can't go into too much detail, but there are a lot of other APIs. So this is just the awareness section where I ramble through a bunch of them. Debugging. If you're debugging stuff and you're using console log, that's awesome. There's more on console than just log. There's a whole bunch of things, and that will help you to format things more nicely so it's easier to read. But it's also timing. You can have timers and timer ends, traces, and console clear, which is like a lifesaver sometimes. Performance. Keep track of your performance to start with. If you do use these APIs to actually have measure points in your app that you can go through, those are amazing to combine with end-to-end testing. Use your end-to-end test to automatically test your performance. Performance observers, highly recommend. Memory, the same way you test your performance, test for memory leaks, especially if you build apps for the web. You would be surprised how rarely users refresh the page. It always blows my mind when I have like a call with a customer and they complain that the list that they loaded like 7 days ago doesn't contain the new records that have been created since then. It's like, yeah, just refresh your page every now and then. Memory leaks can be super nasty in those scenarios, so you can take sample snapshots very easily in the browser. Getting creative. Acknowledged. Getting creative. Again, I'll ramble through these MIDI API, media capture. There's a bunch of stuff you can do in the browser to actually deal with input devices and use the inputs that you get, be it sound, be it video, be it music. All of these allow you to capture. I had the privilege to watch a talk when I was in Europe last month from a guy who's doing crazy shit with like distorting videos and making an art out of it. And he found all of those browser APIs and realized how many artists don't have access to it. So he built websites that give access to all of this crazy functionality through browser apps to a lot of artists, which I think is cool. So definitely check out his website and his stuff. Sharing content, think outside of the box. Do you have actual real devices? Bluetooth, USB are both APIs that are amazing to actually share stuff without having to have internet. Say you build an app and you know your user's not always going to have internet because they use it on the plane or they use it whatever. This is another way to think about, okay, how can I send this from my phone to my desktop so I don't have to redo the whole thing or whatever. Really interesting APIs, both work very similarly. that they allow to send data one way or the other. Next generation. Damn, I thought I would have more time for the Internationalisation API. This has been around for a while, but I still feel like it's not talked about enough. Formatting of anything. So usually when we think about internationalization, it's like dates and all that stuff. That's part of it. Date formatting becomes a lot easier. Relative date and time, that's amazing. Like 3 hours ago, 2 months ago. That localized is extremely powerful. It's stuff that we used to use Moment and all of those big JavaScript libraries for. It comes in the browser now. But it's also just general number formatting, currency formatting, all of that stuff. If you have an international audience, look into those APIs. Even if you don't look into those APIs, those libraries that you use will likely start using those APIs more and more, so they become smaller and smaller. Still win-win. Temporal, I just want to mention because I think that's for me the replacer for Moment and other Day.js and other libraries. It's still, I think, in stage 3. It could be wrong. So that's why the asterisk is there. I think it's still a proposal, but it basically allows dealing with dates and manipulating dates the way it should have been from the get-go, and acknowledges that the current date API is not great. So stuff like adding hours or days or stuff to an existing date is super easy with the temporal API. And the next couple of ones are probably ones that you won't see, but that frameworks like React, like Next.js, like Remix, will start using more and more. Navigation API will replace the History API, again in a similar fashion of like acknowledging that not everything was done perfectly in the first round, so this fixes a bunch of those issues. URL patterns. We can actually finally match URL patterns in the browser for free, essentially. We don't have to pull in heavy libraries to do that. Popover and modal things. And view transitions. This goes more into the HTML part of things, but it's driven by JavaScript, so I'm mentioning them here. If you do popovers, use this API. It comes with all of the accessibility out of the box. Deals with like focus traps, etc. for you. View transition, single page application feeling. Check it out if you don't know what it is. And that's within 45 minutes, I think.